the sigma and gamma values 1, and using the number of compounds in the training set 9888, we get this data. As you can see, for data set 1, the Q square F1 F2 value was just crossing the required threshold, but for data set 2 is not very promising. Q square F1 and F2 values are lower than 0.6, is 0.45. And in case of data set 3, it is more than 0.6. So we have to make it better. Now, how can we make it better? So we have to optimize the sigma values in Gaussian kernel function. So as you can see, as you go on changing the sigma values from 0.25, 0.5, 0.75, and so on, we get the maximum value of Q square F1 and F2 when sigma value is 0.75 in case of data set 1. And data set 3. And in case of data set 2, we get it maximum when it is as the sigma value is at 0.3 gives the maximum. In case of data set 2, when the sigma value Laplacian kernel similarity function, the value of lambda gamma, and we see that in case of data when it is gamma is 1, 2 square F1 and F2. In case of data set 3, some values of Q square or Q square F1.6 and sometimes sigma values 9, and here about 0.9 and some also very low. The effect of number of closed strings on toxicity prediction. Now we have changed number of closed training compounds. It may be not required. So based of closed that actually compounds are not required. So we may get the best results with a 9 in case of data set 1. In case of data maybe high when the number of closed, and sometimes in the there is the one, it may be as low as 5. Three, in all cases, that the Euclidean Laplacian kernel, when the numbers of Q square F1 and F2 and minimum value graphically, the optimization of number of closed compounds or for all source compounds, even 8 source component data sets, we do not require to use all of them. So we have to select training compounds and similarity threshold. Remember, when we are using distance and similarity threshold, we do not use number of closed training compounds because this is already taken care of by the threshold. And as you can see, in case of dataset 1, when you use this distance threshold 0.4 and similarity threshold 0.05, then we are getting your RMSCP. In Euclidean Gaussian kernel Laplacian, distance threshold is 0.5 and similarity threshold is 0. And when the distance threshold is 0.4 and similarity threshold is 0 in all cases. And this is also shown graphically to show the required distance and similarity requirement. So doing all these experiments, that is the optimizing number of closed training compounds, optimizing sigma and gamma value, optimizing distance and similarity threshold, we try to get the best setting possible from where we get the best possible results. And from the best possible result is, in case of Euclidean distance, it is point the Gaussian kernel and Laplacian kernel similarity threshold 0. And in case of, let's say, 3, in case of Euclidean distance, that we have got as the values of RMSEP. And we see that if we want to see our results in terms of classification, in that case, we see that in all the cases of dataset 2 and dataset 3, the sensitivity, specificity, accuracy, precision, FNS are all are 100%. And in case of dataset 1, the sensitivity value is 75%, and the accuracy value of 84%. Rest of them, specificity, precision, these are 100%. So the results are actually very good in terms of classification. So now we have got our best setting or read across prediction and with the previous method. One was also a read across based method, and there was, see, our the values of the quantitative metric all supersede the pre-reported methods. And Q-square A2 for data set 1 is 0.96, but in the previous method it is 0.74 and 0.83. In case of data set 2, our method shows maximum value 0.91, whereas previous method shows 0.80 and 0.83. In case of data set 3, our best method 0.95 based on Euclidean distance, and previous methods are 0.91 in nano QSAR for the small data set. And you can see the maximum value that we have got here, like points, all of them 9. But in 2 of the cases, we have got Euclidean distance as the best method, and in 1 case, we have got Gaussian kernel and Laplacian kernel as the best methods. So graphically, we have also shown this comparison of metrics. Lastly, come to the conclusion from this work. Here we developed read across based on various similarity estimation techniques to use the Euclidean standards for our comparison purpose. We have optimized the sigma, and we have assessed the effect of number of closed training compounds. Actually, all compounds are not required. 2 to 5 the distance and similarity threshold. We have said that suitable distance threshold is 0.4 to 0.5, and suitable similarity threshold is 0.05, 0.00 to 0.05. And simple Java-based computer program has been developed, which is available from this site. And we have shown here this similarity-based read across algorithm can be used for efficient prediction for nanotoxicity of metal oxide nanoparticles. Specifically here, but we can use it for toxicity prediction for other kind of chemicals. In general. So this is a graphical user interface of the software that is available from our website.